This is SpaceTime Series 29, Episode 93, for broadcast on the 5th of August 2026. Coming up on SpaceTime, the strongest evidence yet that Betelgeuse is not alone is the mighty Andromeda galaxy dying, and the most volcanically active world in the solar system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have finally demonstrated that the red supergiant star Betelgeuse has a binary companion star about 2 to 3 times the mass of our Sun. The findings, reported in the journal Astronomy and Astrophysics, provides the strongest evidence yet that one of the biggest and brightest stars in the night sky has a faint stellar companion, Betelgeuse b, orbiting the primary star. Located somewhere between 530 and 643 light-years away, Betelgeuse is the brightest star in the constellation Orion the Hunter and represents the scorpion sting on Orion's shoulder. It's the 9th brightest star in the night sky and one of the largest and most luminous stars visible with the unaided eye. Commonly called Betelgeuse, don't say it 3 times, its name has been tortured through centuries of mispronunciations. It originally started as Betelgeuse, meaning the hand of the big man in Arabic, the big man being Orion the Hunter. Betelgeuse began its life around 10 million years ago as a spectral type OB blue star. Calculations of Betelgeuse's mass range from slightly under 10 to a little more than 20 times that of our Sun, with some 100,000 times the Sun's brightness and around 1,100 times its diameter. In fact, if Betelgeuse were placed at the centre of our solar system, its surface would extend almost as far out as Jupiter, thereby engulfing the orbits of Mercury, Venus, Earth, Mars and the main asteroid belt. Betelgeuse is now a bloated, old, semi-regular, variable red supergiant. Red supergiants are the largest stars in the universe in terms of volume, although they're not necessarily the most massive or luminous. After spending billions of years fusing hydrogen into helium in their cores, a star's core hydrogen supply eventually runs out, and the balancing act between nuclear fusion pushing out and gravity pushing in stops, and gravity wins. The huge mass of the star crashing down on the core causes a dramatic increase in core pressure, consequently temperature. That triggers helium in the core to flash, which causes the helium to start fusing into carbon and oxygen. At the same time, the hydrogen-rich region around the stellar core has moved down towards the core into a region where temperatures and pressures are high enough for hydrogen fusion into helium to commence in the shell around the core. Meanwhile, the increasing core temperature results in increasing luminosity, and the resulting radiation pressure from shell burning causes the outer diffuse gaseous envelope of the star to expand to hundreds of times its previous radius. As the now bloated star's chromosphere or visible surface moves further away from the core, it cools down, turning redder, hence the star becomes a red giant. Sun-like stars eventually lose their outer envelope, which continues expanding outwards, forming a planetary nebula. This ultimately exposes the star's white-hot stellar core as a white dwarf, which will slowly cool over the eons. However, stars with masses of more than around 8 times that of our Sun experience a very different fate. Unlike the Sun, their fusion cycle doesn't end with helium fusing into carbon and oxygen. They've got enough mass to fuse carbon and oxygen in their core into progressively heavier and heavier elements, while shell burning around the core also fuses progressively heavier and heavier elements: carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, nickel, and eventually iron. These stars have become red supergiants. Now, no matter how massive a star is, it can't fuse iron into heavier elements, and so once again, gravity wins, causing the entire mass of the star to collapse down onto the core. The collapse is so powerful that the billions of tons of material causes a rebound, and the star explodes as a core collapse supernova, so bright it briefly outshines an entire galaxy. The star eventually ends up as either a neutron star or an even stranger object called a black hole, singularities of infinite density and zero volume where the laws of physics as science understands them no longer apply. And this will be the fate of Betelgeuse. In fact, it could explode as a core collapse or Type II supernova any day now, which in astronomical terms means it could be tomorrow or 1 million years from now. Whenever it happens, when it does explode, it'll temporarily outshine all the other stars in the galaxy, and it'll be clearly visible in the daytime sky here on Earth. And that'll be a fascinating experience. The last star seen by humans to go supernova in our galaxy was Tycho's star in the year 1572, and that was before the invention of the telescope. This new study's lead author, Miguel Montagas from the Paris Observatory, says astronomers have looked for potential companions as a possible explanation for Betelgeuse's regular changes in brightness. 2 studies published in 2024 predicted that the companion would be furthest from Betelgeuse in December of that year, and hence easier to spot. So Montagas and colleagues used the European Southern Observatory's Very Large Telescope, the VLT, in December of 2024 and spent several months observing the star. And eventually they obtained the clearest image ever of what likely is Betelgeuse b. Montagas says he was concerned he didn't have the sensitivity in his instruments to detect Betelgeuse b because it was thought to be too similar to the Sun in brightness and so it would be obscured by the primary star's glare. But it turned out to be at least 2 to 3 times the mass of the Sun and so could be directly imaged, meaning the light from the star itself was detected. While there has been some early evidence of the possible existence of a companion star, including a possible direct detection by the Gemini North Telescope in Hawaii, this is the strongest evidence for and the clearest image yet of Betelgeuse b. Now, to be certain the companion's really there, the authors still need to observe it in a year's time on the other side of the star. But Montagas believes there's very little space left for doubt. A few years back, Betelgeuse was the subject of attention from astronomers around the world when it visibly started dimming. It quickly went from being the 9th brightest star in the sky to being the 20th brightest. Now, as we mentioned earlier, as an evolved supergiant star, Betelgeuse is expected to explode as a supernova any day now, and so that dimming led some to suspect that this could be what was about to happen. But observations by Montagas and colleagues eventually determined the star was simply being obscured by a cloud of dust. This is space-time. Still to come. Is the mighty Andromeda galaxy dying and the most volcanically active world in our solar system? All that and more still to come on SpaceTime. A new study has found that star formation appears to be winding down in our nearest big neighbouring galaxy, Andromeda. The new findings, reported in the Astrophysical Journal, are based on observations by NASA's Hubble Space Telescope. Astronomers study Andromeda because it provides them with an opportunity to examine its stellar populations in great detail, leading to a better understanding of the past of galaxies like our own. The Andromeda galaxy M31 is located about 2.5 million light-years away, and like our own Milky Way, it's a spiral galaxy. It's close enough and big enough to be seen with the unaided eye from dark skies. It's the largest member of our local galactic group with around twice the diameter of our Milky Way, spanning some 220,000 to 260,000 light-years across. That compares to the Milky Way's diameter of between 100,000 and 120,000 light-years. However, astronomers now suspect the two galaxies probably have similar masses, with both weighing roughly 800 billion to 1.5 trillion times the mass of our Sun. The new observations indicate star formation in Andromeda has undergone a 500 million year decline, with an even steeper drop in the last 40 million years. The findings are based on data from 2 Hubble surveys, the panchromatic Hubble Andromeda Treasury and the panchromatic Hubble Andromeda Southern Treasury. Together, they've mapped 2/3 of Andromeda's disk in ultra-sharp detail. In total, the authors measured about 200 million individual stars across the galaxy, giving them a detailed picture of Andromeda's past activity. One of the study's authors, Ben Williams from the University of Washington, says astronomers need to measure the individual stars because they're the fossil record of the galaxy's formation. And Hubble's the only telescope that can provide high enough spatial resolution over a large enough area to be able to do that in Andromeda. The key is that massive stars are bluer and shorter-lived, while less massive stars are redder and longer-lived. As a result, areas that have experienced recent star formation tend to have a larger fraction of blue stars, while areas with less recent star formation typically have a redder population. So Williams and colleagues divided Andromeda's images into thousands of squares, each spanning roughly 300 light-years per side. And they determined the history of star formation within each pixel in order to gain a comprehensive view of the galaxy's past. Previous research showed that the Andromeda galaxy experienced a dramatic burst of star formation around 2 billion years ago. That was likely due to a past interaction or merger with another galaxy. But since then, star formation has steadily declined. Astronomers measure the rate of star formation in terms of mass, or the amount of gas and dust converted into stars every year. The authors calculated that 500 million years ago, Andromeda formed stars at a rate of about 1 solar mass per year. That's about the same as the Milky Way today. However, the formation rate dropped in Andromeda to about half of that figure by about 40 million years ago. The current rate has now plummeted even further, to just a fifth of the mass of our Sun per year. They also examined whether that decline was consistent across the entire galaxy or just concentrated in certain specific areas. And they found that much of the recent star formation occurred in a star-forming ring located around 32,000 light-years from the galaxy centre. As a result, much of the decline they measured was driven by decreasing activity within that ring. Rather than being the result of reduced material from which new stars can form, the authors think the declines are more likely to be a natural winding down from its previous more active state. Williams and colleagues also investigated whether there was any connection between the decrease in activity in Andromeda and its proximity to the satellite galaxy Messier 32. M32 is separated from Andromeda by about 16,000 light-years in the plane of the sky. However, its 3D location in space is uncertain. As a result, astronomers are unsure if or when it might have interacted with Andromeda in the past. Survey data from the panchromatic Hubble-Andromeda Southern Treasury allowed the authors to study the history of star formation in Andromeda near M32, and they found this area showed signs of decreased star formation compared to other regions. The timing of this decrease, which the study finds began roughly 60 million years ago, could help constrain when M32 interacted with Andromeda's disk. The authors say they can't explicitly say they're seeing a decrease in star formation because of M32, but hey, it's right there. And it's definitely the most likely suspect. This is Space-Time. Still to come, the most volcanically active world in the solar system. And later in the science report, a new study warns that mining is now a threat to more than 12,000 species across the planet. All that and more still to come on Space-Time. NASA's Juno spacecraft has provided the first measurements of the temperature below the surface of Jupiter's volcanic moon, Io. The findings, reported in the Journal of Geophysical Research Planets, show significant heating within the shallow subsurface of what is the most volcanically active world in our solar system. Collected during 2 close flybys, the data also shows that most of Io's surface is remarkably smooth and composed of material with very low density. Io's extreme volcanism is powered by tidal heating. See, the moon's constantly being stretched and squeezed by the immense gravity of its host planet Jupiter as it travels in its slightly elliptical orbit around the gas giant. Then there are further gravitational tugs during its journey from its sister Jovian moons. Io is the innermost and smallest of Jupiter's 4 Galilean moons, but the 3,660-kilometre wide world is still slightly larger than the Earth's moon. Until now, virtually everything astronomers know about Io's tidal heating has come from infrared observations, which can really only sense the temperature of the surface. But these latest findings are based on data collected by Juno's microwave radiometer. Juno principal investigator Scott Bolton from the Southwest Research Institute in San Antonio, Texas, says the surprising discovery that we can see below the rocky moon's surface has important implications for studying volcanoes here on Earth. He says Juno's taught scientists that if they look with a microwave radiometer instrument near a volcano on Earth, they might see similar signatures in the subsurface temperature gradient, providing new information on how Earth volcanoes work. Juno's microwave radiometer was designed by Bolton to peer beneath Jupiter's cloud tops in order to investigate the dynamics and composition of the gas giant's deep atmosphere. Its 6 microwave antennas act as a single instrument, simultaneously detecting microwaves at a range of different wavelengths. During Juno's extended phase, it's provided scientists an opportunity to observe 3 of the planet's so-called Galilean moons, Ganymede, Europa and Io. So far, only Callisto has been left out of the study. They're called Galilean moons because they were first observed by Galileo Galilei when he turned his telescope onto the orb of Jupiter. Seeing the moons orbiting around Jupiter, Galileo realized that the Earth and all the other planets in the solar system were simply doing the same thing around the Sun. A discovery which ended with him not only being sentenced to house detention by the Catholic Church for the rest of his life, but he was also forced to renounce his discovery on pain of death. Yet Even then, under his breath, he whispered, "And yet it moves," referring to Earth orbiting around the Sun rather than the Earth-centric view of the universe favoured by the Catholic Church at the time. Bolton says each wavelength within the microwave radiometer explores different depths, providing a new way to characterise the deep atmosphere of the giant planets, as well as the subsurface crusts of icy and rocky moons. At Ganymede and Europa, Juno explored tens of kilometres below the surface, assuming their ice shelves were mostly pure water. But the ability to probe the volcanic rock on Io was an unexpected discovery. During flybys on December the 30th in 2023 and February the 3rd in 2024, the Juno spacecraft came within 1,500 kilometres of Io's surface. Bolton and colleagues found that everywhere they looked, they saw temperature increases of roughly 5 degrees Celsius every few centimetres, a far steeper gradient than solar heating alone can explain. And that suggests only two likely explanations. Either the heat is rising steadily through a conductive crust, or the signal could be coming from cooling lava flows, capped by roughly 10 metres of solidified crust, covering about 10% of the Moon's surface at any given time. Bolton says Io provides a unique window into how tidal heating works throughout the cosmos, a fundamental process providing energy and heat to worlds that could be orbiting far from the host star. This process not only creates the most volcanically active world in our solar system, but it also fuels the subsurface oceans on the ice moons of the giant planets, like Europa, Enceladus, and Ganymede. Another major insight gained from Juno's two flybys of Io is just how smooth the little world is. Before these findings, the Moon was known for its tall mountains, but the new observations indicate that apart from this visible topography, the surface features expansive smooth patches that can stretch for hundreds of kilometres or more. Because Juno flew by overlapping regions of Io at different angles, the authors were able to map just how the surface reflects microwaves, showing them just how flat this distant world really is. But of course, Io has an ever-changing geography. Living on Io, you wouldn't have weather reports, you'd have geological reports, with lava lakes forming in the north, mountain building in the south, and ground solidification in the west. This report on Juno's mission to Jupiter comes from NASA TV.
Humanity has had its eyes on Jupiter for centuries. First, telescopes, and in recent decades, 8 deep space probes were used to examine the largest planet in the solar system. Equipped with unique sensors, Juno looked deeper into the planet's structure than ever before to find out the answers to basic questions about Jupiter's makeup and how it formed.
Juno's looking for how Jupiter formed and really how planets are made in general. We're very much looking for the recipe for planets. The special thing about Juno is we're really looking at one of the first steps, the earliest time in our solar system's history. Right after the Sun formed, what happened that allowed the planets to form, and why are the planets slightly different composition than the Sun?
Jupiter is so far away from Earth that even when it's at its closest to us, it will still take a radio signal moving at the speed of light about 34 minutes to cross the distance.
Pretty challenging missions, pretty challenging payloads. I'd say it's pretty robust.
So it's those kind of challenges with making sure you do all the little things necessary to maximize the opportunities that you get.
Aside from distance, Jupiter offers unique challenges to a spacecraft, such as a radiation field rivaled in intensity only by the Sun.
We have a box in the middle of the spacecraft that we call a vault, and it's made out of titanium, and that shields all the electronics from these hazardous radiation. And we're very much an armored tank going to Jupiter.
Just as Juno is building on the knowledge gained with past missions to Jupiter, future missions will build on Juno's findings.
If we can start to understand the role that Jupiter played in how the planet formed and how that eventually governed the creation of the other planets and Earth and maybe even life itself, then we know a little bit about how to look for other Earth-like planets maybe orbiting other stars and how common those might be and the roles that those giant planets that we see orbiting the other stars play.
Really all these missions that LSP is involved in and NASA is involved in are all precursors to the bigger picture of getting humans out beyond low Earth orbit to Mars to an asteroid and beyond.
And in that report from NASA TV, we heard from Juno Principal Investigator Scott Bolton from the Southwest Research Institute in San Antonio, Texas, as well as Juno Launch Director Omar Bays and Juno Mission Manager John Colvert, both from NASA. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that mining is now a threat to more than 12,000 species across the planet, which includes almost 6,000 that are already listed as threatened. The findings, published in the journal Cell Report Sustainability, overlaid the space where mining occurs across the planet and noted that 28% of the ranges of threatened species overlap with those areas that are being mined. The authors say at least 100 species have some 75% of their ranges overlapping in these areas. That's despite mining not being recognised as a threat by the International Union for Conservation of Nature. They also found that future planned mining sites could expose over 3,000 threatened species to the risks involved around mining sites, 83% of which don't have a mining-related threat designation. A new study claims taking faecal capsules could help people with insomnia get a good night's sleep. A report in the Journal of Internal Medicine claims a trial involving 40 people who had chronic insomnia disorder were given either a placebo or an antibiotic treatment to clear their gut microbiome and then faecal pills to recolonize their intestinal tract. After a month, the participants receiving the faecal pills showed greatly improved sleeping patterns compared to those on the placebo. The subjects taking the pills also reported feeling that their sleep had improved for up to 6 months after taking them. Well, despite Australia's air being relatively unpolluted compared to other parts of the world, a new study has found that there's a clear link in the Great Southern Land between air pollution exposure and the risk of ending up in hospital with lung and heart issues. The findings, reported in the journal Public Health Research and Practice, used national air pollution estimates from 2016 and hospitalisation data from 1,155 public health areas between 2016 and 2017, representing some 23,236,046 people. The authors found higher exposure to pollution particles smaller than 2.5 nanometers, together with nitrogen dioxide, was consistently linked with increases in hospitalisations for these issues. A new study has found that people who spend an excessive amount of time online tend to be more stressed, have worse moods, and neglected other parts of their lives. A report in the journal PLOS ONE monitored the daily internet use of some 900 German adults for 2 weeks. The authors found temptation was the biggest thing pushing subjects to go online. However, although excessive internet users had worse moods, spending time online didn't improve how they felt. Telstra, Australia's largest telco, is expanding its relationship with Elon Musk's Starlink broadband satellite network. Right now, the Starlink constellation includes some 10,413 satellites in low Earth orbit, and Telstra wants to take advantage of that. With the details of the new Telstra Starlink deal, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Yeah, well, they're calling it a first for Australia. Satellite to mobile connectivity expands from text to apps. Now, before you suddenly think, I can get a high-speed bandwidth from the sky. No, this is for low data users, and they were the first to launch satellite messaging in Australia. This was to send messages beyond the range of their mobile network, but now they're rolling out access to select satellite apps to eligible consumer and small business customers. So this is where their collaboration with Starlink, there's now a selection of satellite optimized apps, and this includes things like navigation apps, Apple Maps, Google Maps, All Trails, messaging apps including iMessage, WhatsApp, Facebook Messenger, Signal, and Google Messages. You've also got weather apps, Apple's Weather, AccuWeather, and Google Weather, and then also Google Fitness, and of course the My Telstra app. And these are apps that have been specifically optimized to send and receive data over what is effectively intermittent satellite connectivity. Over WhatsApp, you can do voice and video calls, but it's going to drop out. You just want to send text messages. But eventually, you will have a lot more direct-to-device capability from updated Starlink and other satellites that are designed to connect directly to mobile phones and give a proper higher bandwidth experience. And this will work with iPhone 13 or newer, the new Samsung Galaxy S26, and it will expand to some of the older Galaxy range by the end of the year. It's really particularly for people who are outside of the mobile network. And it will mean that, over the next few years, you will have a lot more services connecting directly to satellites without needing a special sat phone. And it's going to put into question what you need to be connected to your local provider for. I mean, there will come a time when Starlink, Elon Musk will just have a global plan. And he's really talking about wanting to buy existing telcos for their spectrum or bidding on spectrum services so that he can have terrestrial and satellite connectivity. And imagine if you just had a global plan through Starlink that worked with any phone. It'd be pretty cool.
During the 13th test flight of the Starship, on board that Starship were 20 test versions of the Starlink version 3 satellites. They're a little bit bigger than the current version 2, and they're the ones that will in fact allow every cell phone to become a satellite phone for voice, video, everything. And that's how close we are. So we just need to get more of those satellites up there.
And look, the thing about the satellites is that, I remember when, 3 or 4 years ago, Elon was talking about launching version 2 satellites. So here we are in 2026. He's launching version 3. And these satellites, they're not permanent fixtures in space. They, slowly get out of orbit. They're only supposed to last 5 or 6 years before they have to be deorbited anyway. That's why he keeps launching new satellites all the time and replacing them with more advanced ones, which have these extra capabilities. Every time he launches new ones, as you just explained, after a certain period of time, there'll be a version 4 and a version 5.
And that's part of what Starship's all about. Whereas a Falcon 9 can launch maybe 28 satellites in a single bounce, the Starship will launch 60 at a single go. 60 satellites each launch. That's pretty cool.
Yeah, it is. And that's how, of course, you build out the constellation quickly. We did have the situation where a couple of months ago, Jeff Bezos' Blue Origin satellite, which was meant to launch a bunch of the next-gen Amazon LEO satellites that NBN in Australia wants to upgrade its SkyMaster network with. And, that explosion blew up a whole stack of those satellites and blew up most of the launch pad with it. I was reading that it normally takes 12 to 18 months to rebuild the launch pad, but Blue Origin is determined to get it up by the end of this year, by December 2026.
Yeah, the Russians said that problem too a couple of months ago when a Soyuz launch destroyed the launch pad. The Soyuz was fine, the rocket was fine, but the launch pad, it had gone to whatever launch pad heaven there is. And they thought it would be at least 2 years before they could get people back into space because this was their only launch pad designed to carry manned spacecraft. Yet in 9 months, they completely replaced it and they were back up and running. So Jeff Bezos saying he'll do it before the end of the year. Yeah, I believe that.
Yeah, well, what I read was it'll be approximately 6 months and it's going to be just enough launch pad for the launch. I'm sure they'll keep upgrading it, but he needs to get the Amazon LEO satellite constellation up and running. And to do that, you need another rocket.
Dude, I remember as a kid watching James Bond 007 Moonraker and thinking to myself, how ridiculous, private people having their own launch systems. Now it's happening.
It's no longer science fiction.
Yesterday's science fiction is today's science fact.
Absolutely, absolutely.
That's Alex Zaharov-Reutt from TechAdvice.life. And this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.